After decades of mystery, speculation, and myriad theories, the James Webb Space Telescope has finally presented something that may change our knowledge of the universe. Its first genuine high-resolution images of Betelgeuse, the enormous red supergiant that has long captivated scientists and the general public, have arrived. For decades, it was thought that Betelgeuse would explode in a brilliant supernova, a heavenly spectacle that would shine briefly as bright as the sun and radically change our nighttime sky. But what Webb has recorded has surpassed even the greatest expectations, leaving astronomers amazed, fascinated, and wanting to know more. Are we seeing a stellar event never encountered before? Or is there something Betelgeuse is concealing even stranger than we can imagine? Betelgeuse is probably our most mysterious and gigantic star in our local neighborhood, evoking awe through the ages. Its stupendous size, approximately 1,400 times bigger than our Sun, and its brilliant reddish hue have predisposed it to be a prime target of amateur observers and professional astronomers alike for centuries. Situated in the Orion constellation shoulder, Betelgeuse has always been a source of fascination. Ancient cultures saw its bright color and beauty and made it the subject of myth and legend. More recently, it was used as a standard star by astronomers, one that appeared fixed in the sky, until it didn't. Last year, Betelgeuse was the focus of intense scientific examination for a completely unexpected reason. It started to fade, and it faded quickly. For as bright a star as Betelgeuse, this sudden and spectacular decrease in light was shocking. It sparked a frenzy of guesswork. Was this the start of the end? Was the star on the verge of blowing itself up in a brilliant supernova that would shine even in daylight? The prospect excited the astronomical community and the general public, offering the thrilling possibility of viewing a one-time event from our own cosmic neighborhood. Newspapers, science websites, and TV news channels hummed with anticipation. Social media was filled with tweets from professional astronomers and amateur skywatchers alike. Everyone was asking, was Betelgeuse going to explode? As anticipation grew, telescopes worldwide pointed toward the giant, monitoring its anomalous behavior eagerly. But even with the unsettling flickering and dimming, the predicted explosion never materialized. Instead, Betelgeuse's luminosity varied erratically. It would fade, then light up, then fade again. The long-sought supernova eluded it. This perplexing pattern left astronomers both intrigued and frustrated, yearning for more data that could reveal the secret behind the star's unpredictable fluctuations. The enigma only grew deeper with each observation. That's where the James Webb Space Telescope came in. A success of human ingenuity and cooperation, Webb was sent to look deeper into the universe than ever before. It did not overnight. Its construction took decades, involving the tireless efforts of thousands of scientists, engineers, and technicians worldwide. Webb also comes with a 6.5-meter gold-coated mirror, which consists of 18 hexagonal pieces that folded up like an origami to fit within its rocket before expanding perfectly in space. Its cutting-edge infrared detectors are able to detect light unseen by the naked eye, light that has been traveling for billions of years throughout the universe, and light that is able to penetrate dust and gas clouds that block regular telescopes. Webb's initial purpose was to investigate the very first galaxies, to look back in time to only a few 100 million years after the Big Bang. But its capabilities also make it ideal to observe stars near home, stars such as Betelgeuse that are engulfed in dust and turbulent gas. For scientists eager to crack the Betelgeuse enigma, Webb was the ideal instrument. Months of waiting finally saw scientists point Webb's unprecedented eye towards Betelgeuse. When the initial high-resolution shots were received, they did not merely live up to expectations, she exceeded them. What was delivered by the James Webb Space Telescope was stunning to behold and scientifically jarring. Thanks to Webb's keen infrared eyes, Betelgeuse did not look like a dying ember on the brink of demise. Rather, it developed as a stormy giant, teeming with energetic and flamboyant activity. Its surface, initially conceptualized as fairly stable, proved to be deliriously chaotic, characterized by enormous hot spots and radiating patches. These were not trivial features, they were manifestations of furious large-scale phenomena occurring on the star. Webb's observations indicated that Betelgeuse was losing tremendous amounts of its outer layers in gigantic eruptions called stellar mass ejections. These outbursts flung gas and dust into the interstellar space, creating huge, irregular clouds that enveloped the star like a heavenly curtain. The apparent sign of dying, the dimming of the star, was actually caused by these wild fits. As the material expelled by these outbursts cooled and spread between Betelgeuse and Earth, it blocked the light from the star, giving the impression of a dying star. This discovery fundamentally changed scientists' explanations of Betelgeuse's behavior. Instead of advancing quietly toward the end of its life, the star was experiencing violent, turbulent cycles that remodeled its outer atmosphere in breathtakingly short timescales. Whole areas of the star would brighten or dim in a matter of weeks, a blink of an eye astronomically, especially for a star of this enormous size. Betelgeuse was not quietly disappearing into the night, it was roaring, shaking, and expelling its outer layers in spectacular outbursts. These were causing hot debate within the astro community. Some scientists interpreted the spectacular changes on the surface as proof that Betelgeuse is indeed moving toward its ultimate evolutionary stage, hopefully in just a few decades short of a supernova explosion. Others suggested that the star could be going through a period of extreme non-terminal instability, a severe but extended series of convulsions that might persist for years, even centuries. Whatever perspective eventually turns out to be correct, one thing is certain: Betelgeuse is acting in ways that we have never seen directly with a star of this type. What Webb has given us is not merely a detailed snapshot of a single star's surface, but a profound challenge to our understanding of how massive stars evolve. For decades, astrophysicists have modeled the life cycles of massive stars, mapping their births, long stable lifespans, and fiery deaths in supernovae. But Betelgeuse's antics indicate that the last days of a star's life could be much more hectic and disordered than our simulations have explained away. Rather than a smooth trajectory toward collapse, the end could be characterized by unprogrammed crises, turbulent, gigantic explosions that alter the star's very structure and its surroundings. These findings have huge implications. The birth and demise of superlarge stars aren't mere cosmic wonders, they're at the heart of the universe's tale and our own. When a star like Betelgeuse finally blows its top, it will eject huge amounts of heavy elements into space: iron, oxygen, carbon, and more. These are the materials planets, atmospheres, and life are made of. With each breath, every cell in our bodies have atoms that have been produced in the heart of a long-dead giant star. Observing Betelgeuse in its terminal turbulent phase, therefore, is not simply observing a giant die, but also seeing the processes that made our own existence possible. It is a feat that the James Webb Space Telescope has now rendered possible for the first time. Its telescopes enable us to see the universe in greater depth than ever before, from the seething surface of Betelgeuse to the first galaxies forged in the aftermath of the Big Bang. Behind every stunning photo and stream of data is a testament to engineering skill. Conceive of a gold-eyed, tennis court-sized observatory folded up origami style to go into a rocket, then magically unfolding with breathtaking accuracy in space. Webb's enormous mirror, segmented and gold-coated to capture maximum infrared sensitivity, gathers the dimmest light from the farthest distance in the universe. Its cameras can penetrate cosmic dust that obscures visible light, bringing into view stars and galaxies that were invisible until now. This capability to penetrate the dusty veil around Betelgeuse is the very thing that enabled these new findings. But behind each pixel of information are the people whose stories made it all happen. The James Webb Space Telescope is the culmination of decades of planning, innovation, and international collaboration. Thousands of engineers, scientists, and technicians worldwide overcame immense obstacles to bring Webb into existence. Each finding made possible with Webb moves us toward answers, even as it creates new questions. As we go on gazing at Betelgeuse and other wonders of the sky, we are reminded that the universe is a universe of infinite complexity and surprise. Webb is not merely an astronomical instrument, it is a time machine, showing us a view of both distant past and uncertain future of the universe. With every new observation, we are called upon to dream larger, to ask more profoundly, and to marvel at the boundless interwoven universe that we inhabit. Observing Betelgeuse's explosive last stage is an undertaking more than scientific, it's one of philosophy. It's a reflection on a celestial cycle of endings and beginnings, a testament that even in annihilation, seeds for creation are planted. The materials that will eventually create new stars, planets, and perhaps life itself are being flung into the unknown by Betelgeuse before our very eyes. This knowledge changes our perception of the night sky. It is no longer a static backdrop of starlight, but a living, breathing, changing system, a system in which we are deeply involved. The destiny of stars such as Betelgeuse is akin to our own in the cosmic tapestry. Even our sun, much smaller and longer lasting than Betelgeuse, will eventually experience its own change. It will not go supernova, but it will ultimately shed its outer atmosphere, creating a planetary nebula and recycling its material back into the galaxy. This common destiny connects all stars into a great cycle of death and rebirth, a cosmic recycling that constructs the universe afresh again and again. As Webb looks on toward Betelgeuse and further, it doesn't merely impart new information to us, it provides context. It reminds us that the universe is not something separate from us. It is our origin, our context, and our destiny. Every discovery made with Webb enriches our understanding and deepens our appreciation for the beauty, complexity, and interconnectedness of the cosmos. As the telescope keeps working, unveiling everything from the atmospheres of exoplanets to the turbulent cores of distant galaxies, we can be certain the tale of Betelgeuse is only the start, and the universe still has plenty of secrets to reveal.